All right, so let's talk about some inverse trig derivatives. At the beginning of the year, we talked about some inverse trig, arcsine, arctangent. So we're going to have to think back to that, and we're in fact going to find the derivatives of those things. So let's just take a minute to remember that if the cosine of pi over 6 is the square root of 3 over 2, then inverse cosine or arc cosine, however they mean the same thing, of square root of 3 over 2 equals pi over 6. So again, we can write them as arc cosine or kind of this notation, inverse cosine, and they mean the same thing. If you recall, there are only certain intervals that you look at when you're doing the arc trig functions. If you remember that for arc cosine, you looked between 0 and pi, which means every answer that you give, it's arc sine of something, every answer that you fill out will need to be between 0 and pi. And then with arc sine, you were looking in quadrants 1 and 4, and so that continuous interval is negative pi over 2 to pi over 2. And arctangent was the same interval, pi over 2 to negative pi over 2. Now, you're not going to give those because I probably wouldn't ask you about arctan of undefined. So that's why they're open brackets at the pi over 2's, because tangent is not defined there. But as far as the quadrants, you look at the same for arcsine and arctangent. So remember, when you were in quadrant 4, you had to name negatively, meaning if I was trying to say this angle right here in particular, I wouldn't say 11 pi over 6, I would say negative pi over 6. So we have negative pi over 6, negative pi over 4, negative pi over 3, and then, of course, negative pi over 2. Those are your unique choices. So let's just take a second and see if you can do these 6 arc trig functions. So stop the video and see what you think. All right, so here we go. Arc sine square root of 2 over 2. Give me the arc who has a sine of square root 2 over 2. That would be in quadrant 4. The positive ones are easy because you know you're going to be in quadrant 1. So those are the easy ones. Arc cosine of negative 1/2. Remember, I'm going to be looking in quadrants 1 and 2. If cosine is negative, that's going to be in quadrant 2. So negative 1/2 would be about there. So that's 2 pi over 3. Arc sine of negative square root 3 over 2. That means long in the y. That's this guy down here. But how do I name him? Be careful. Don't say 5 pi over 3. Say negative pi over 3. What arc has a tangent of square root 3 over 3? Or I could say 1 over square root 3, meaning the same thing. That's the pi over 6. What arc has a cosine of 0? Remember, I'm only looking in here. Which one of those has a cosine of 0? Do I not go anywhere in the x direction? That would be pi over 2. And finally, who has a tangent of negative 1? You know it's the pi over 4's, and because it's negative, remember I name it as negative pi over 4. Okay, so now that we have that evaluating in there, that's important because if you have to evaluate one, and when we integrate later, you'll have to know those values. So let's figure out the derivative of arcsine. So it's actually kind of cool where this comes from. You would agree, kind of like I did up here, that I said if the cosine of pi over 6 is square root 3 over 2, okay, and I have the inverse cosine of square root of 3 over 2 is pi over 6, I'm kind of going this way. Then the cosine of pi over 6 would be square root of 3 over 2, so kind of the same thing. If y equals the arc sine of x, that means y is the arc that has a sine of x. I could write that the sine of y is equal to x. Now let me use implicit. If I used implicit differentiation and took the derivative with respect to x, The derivative of sine of y would be cosine y dy dx. And then, of course, the cosine of x is equal to 1. So I could get dy dx. The solving is pretty easy. 1 over cosine of y. But I want to write my answer in terms of x. So let's remember, let's look at some trig identities. Gotta love trig identities. I'm trying to get cosine of y in terms of, put that in the wrong spot, sorry. Cosine of y in terms of something with x in there. So we all, I think, would agree that sine squared plus cosine squared equals 1. So if I wanted to solve for cosine squared, that would be 1 minus sine squared. And in the same way, I could take the square root. Now, technically, when I take the square root, yes, I would need a plus or minus, but because we are talking about quadrant 1 at this particular moment, then I'm going to go with the positive. And so here we go. Looky here. Interesting enough that I get the cosine of y is the square root of 1 minus sine squared. But now just a second. Look back from the very beginning. If sine of y is x, I could write that the cosine of y in terms of x would be 1 minus x squared. So that's pretty cool. So really, right here, I could write dy dx is equal to 1 over the square root of 1 minus x squared. And that's my derivative. Now, of course, when I go, I just want to show you where one of them came from. I could certainly derive all of them, but in reality, you're not going to memorize the derivation. You're just going to memorize the formula. As you've done all unit long, memorizing the formula is going to make your life so much easier. So that's just to show you where it was, and you know that, of course, this argument is not going to be x. So what does it come down to? Well, it comes down to this. The derivative of arc sine of u, where u is some function of x, just like we did, we got the square root of 1 minus u squared on bottom. But remember when it was just x, when it was arc sine of x, the derivative of that, we got 1 over 1 minus x squared. What is the derivative of x? 1. Well, that's what shows up here. So what this really is, if it's something more than just x, it's u prime. So I memorize u prime over the square root of 1 minus u squared. The cool thing with arc cosine, if you look, I have that, just slap a negative in front of it. And that's arc cosine. Arc tangent is u prime over no square root 1 plus u squared. Okay, people, once you have those formulas memorized, the derivatives should be very, very easy. Look at example 1. What's the derivative with respect to t of arc tangent of t squared? This is my u. Now I've got it memorized, and what I would do on my homework every single time, I would just write down, and I know we just did, u prime over 1 plus u squared. If you'll write it down, you'll probably remember it and have it memorized by the time you finish your homework. So if u is t squared, I actually do the bottom first. I would have 1 plus t squared squared, 1 minus u squared, which of course that is 1 plus t to the 4th. And what goes on top? The derivative of u. So that's 2t, and there's my derivative. Easy, easy. The derivative of arc cosine of 3x. Arc cosine, what is that? That's u prime over the square root of 1 minus u squared, but it has a negative in front. This is my u, And you're probably fast enough that you're like, you know what, I can square 3x in my head. Make sure you square the number in the letter. So that's 9x squared. And then what is u prime? That's a 3, slap a negative, and it's just that fast. And you certainly would not say that the square root of 1 minus 9x squared is 1 minus or plus 3x. You would never, never say such mathematically horrific things. So you just leave it like that. Could I have more trig functions? Well, of course. Doesn't make it any different. That's your u. The derivative of arc sine is going to be u prime over the square root of 1 minus u squared. So what do I got? I have my derivative is going to be the square root of 1 minus tangent squared, because that's my u. Now what is the derivative of tangent? The derivative of tangent is secant squared. And there we go. That's my derivative. Easy, easy. So that's it. Now again, I went over the values because if I say write the equation of the tangent line or something like that, you're going to have to know those values. I do want to go over one thing to get a simplified answer. So I just want to, I know this is not on your sheet, but kind of there's probably plenty of space there. If I ask you to simplify this number, I just want you to see this because you know there's going to be, with fractions, there might be a chance of a complex fraction or compound fraction. So I just want to go over some simplifying because with multiple choice, as you know, it will lend itself to simplified answers. So let's simplify this. When you take the square root, this 1 minus 1/4. Now here I, of course, have a, you can know that in your head because you're like, yeah, I can subtract 1 minus 1/4. But if you have a variable, what you really do, so I'm going to pretend this 1, I'm going to make that 4 over 4. So I'm going to get a common denominator. And then I'm going to subtract my numerators, and I'm going to, of course, keep the denominator. Remember when you take the square root, you take the square root of the top and bottom. So I could take that square root on the bottom and write it like that. And if I did that, of course, then I would have 1/2 times the reciprocal, 2 over square root of 3. The 2's would cancel, and I would get 1 over square root of 3. And like I mentioned before, in free response, that is a perfectly wonderful answer to give. They would give you full credit. If it's multiple choice, you look at the answer choices. They may have the square root of 3 on the bottom. If they don't and they rationalize, yes, you have to know that those two things are the same. But I just wanted to make sure you realized kind of how to do a simplifying because you're going to have to do that on your homework. So there you go. And good luck, everybody.